Welcome to one and all. Today we are going to see one operational techniques in quantitative techniques in management is known as the assignment model. So what is assignment model? Assignment is a typical optimization technique practically useful in a situation where a certain number of tasks are required to be assigned to an equal number of facilities on a one-to-one basis so that the resultant effectiveness is optimized. For an example, job to be assigned to machines or to workers, salesmen to sales area, task to workers, programs to programmers, or vehicles to routes, etc. So always remember one important note which is used in assignment problem or in assignment model. Assignment problem is a case of transportation problem where a number of sources is equal to the number of destination, that is m is equal to n, or number of rows is equal to number of columns, and the supply and demand figures for each of the sources and destination is always 1. So while solving the assignment problem, we used the Hungarian methods or flood techniques. So what are the steps are involved in? The steps are involved in as follows. Step 1. In a given matrix assignment table, subtract the smallest element or number in each row from every element in that row. Step 2. Subtract the smallest element in each column from every element of that column so as to get a reduced assignment matrix. Step 1 and 2 can be interchanged. Step 3. Draw minimum number of vertical and horizontal lines necessary to cover all zeros in the reduced matrix by inspections or by observations. Start with the rows or columns having maximum number of zeros to draw the lines. Now, if the number of lines is equal to number of rows and columns, that is n, it implies that the solution is optimum. Then go to step 4. If the number of lines is less than n, then the solution is not optimum and it needs further improvement. Then go to step 5. Step 4. Make the assignment as follows. First, check the rows successively. Mark a square around a single unmarked, that is free zero in a row if present, and cancel all the other zeros in each column. Second, check the column successively. Mark a square around a single unmarked, that is 0 in a column if present, and cancel all the other zeros in its row. Third, repeat step 1 and 2 above until all the zeros in the matrix are either marked with a square or cancel out. Now the square zeros represents the assignment, and if there is exactly one assignment in each row and column, it indicates an optimum solution. Consider then corresponding element in the original matrix to find out the optimum value of the payoff, bracket, time and cost, etc. Step 5. If the solution is not optimum, then select the smallest element among all the uncovered element of the reduced matrix. 2. Subtract it from the all uncovered element and add it to the elements at the intersections of lines are held, keeping other elements unchanged. Then go to step 3. Draw the lines and repeat the procedure until the number of assignments is equal to the number of rows, that is optimum solution is obtained. Now let's move to problem. Problem number 1. How should the job be assigned so as to minimize the processing cost? Here the number of jobs are given to us 3, 1, 2, 3, and machines are given to us 1, 2, 3. So here we need to find out the job must be assigned to with respect to the machine so as to we need to minimize the processing cost. So write down the table with the matrix. So here we need to apply the Hungarian methods or flood techniques. So our first step is step 1, row subtraction. Select the smallest value in each row and subtract this value in each value in that row. So see, in a first row the minimum value is 5, in a second row the minimum value is 10, and in third row minimum value is 30. So subtract this minimum value in each row and let's find out the answers for it. So see, in a first row the minimum value is 5, so 5 minus 5 0, 7 minus 5 2, 9 minus 5 4. Move on to next row, row 2, minimum value is 10, so 14 minus 10 values comes 4, then 10 minus 10 0, then 12 minus 10 2. Then move on to next row, row 3, the minimum value is 13, so 15 minus 13 2, 13 minus 13 0, 16 minus 13 3. So here we completed our step number 1 in Hungarian methods. Now move on to step number 2. Step number 2 is select the smallest value in each column and subtract this value from each value in that column. So by observation you can identify it in a clear way. In a first column, machine 1 column, having the minimum value is 0. Now next move on to next column, column number 2, again the minimum value is 0, and next column, column machine 3, the minimum value is 2. So now check it out, the values comes in this way. For the first column the minimum value is 0, so 0 minus 0 values comes 0, 4 minus 0 4, 2 minus 0 values comes 2. Next move on to 2, machine column number 2, machines 2, minimum value again 0, so all values remains as it is, so 2 minus 0 2, 0 minus 0 0, 0 minus 0 0. Move on to next column, column 3, 4 minus 2 2, 2 minus 2 0, 3 minus 2 is 1. So here we completed our step number 2. Now move on to step number 3. Step number 3 is draw the lines which covers the maximum number of zeros. So step number 3, by inspections or by visualizations you can clearly identify it that the maximum number of zeros are lies in row 2. So draw the lines which covers the maximum number of zeros by drawing the lines as a horizontal way. So next move on to first row, draw the lines which covers the maximum number of zeros. Then next row 3 having the single zeros, again draw the horizontal lines which covers the that particular zeros. So here our number of lines are equal to the number of rows and columns. Is number of lines are our 3 and number of rows and columns are 3. Therefore your solution is a optimum. So make the assignment as follows. So job 1 we are going to assign to machine 1 and cancel out the other successive zeros if it is present in that particular rows as well as in columns, but in both way here there is no other zeros are present, so leave it. So next move on to job 2. Job 2 to machine 2, cancel out the other successive zeros in that particular rows. Yes, it is present, so cancel it out in column wise as well as in a row wise. But here assignment of job 3 cannot be done, but we are saying that our solution is optimum, means here our allocations are wrong. So again improve, we are going to improve in this way. Job 1 we are going to assign and cancel out the other successive zeros if it is present, but here there is no other zeros are mentioned, so leave it. Then job 2 to machines 3 and cancel out the other successive zeros. Then job 3 to machine 2. So here our assignments are made at 0 values, therefore we assign job 1 to machine 1, job 2 to machines 3, job 3 to machines 2. So in this way, job 1 to machine 1, the cost is given to us in original matrix table is 5. Then job 2 to machines 3, the cost is 12. Job 3 to machines 3, cost is 13. The summation of total is 13. So minimum processing cost is required for making of this job with respect to the machines is total rupees 30. Now problem number 2. This is for your practice purposes. Thank you.